These are algae biomicro-robots created at the University of California, San Diego in Joseph Wang's laboratory. And as you can see, they're for treating the lungs. The little yellow dots are actually little medicine packets that are on the outside of the algae. And you can see the algae also have their little flagella that they can use to swim around in bodily fluids. So all they had to do was take these algae, centrifuge them down, and then wash them with ultra pure water. And then they were able to add this molecule to the water and get it to attach to, all over on the heads of these algae. This big thing right here, this molecule here, is actually the cancer drug. This is the cancer drug they used, doxorubicin. And basically what they did was they centrifuged down a bunch of red blood cells till all that was left was the cell membranes. And then they were able to throw in that cancer drug, shake it up, and it got coated with those membranes. And then they were able to stick that on to this molecule over here. And the idea was take all these algae that have that medication attached to them, go through the trachea and inject it into the lungs. So they got a bunch of mice that were infected with lung tumors and inserted the drug along with the algae through the trachea into those tumors. Obviously, there had to be controls, and you can see these different colors on this graph. The red are the mice that were treated with the algae. And then the black is just saline solution. And then the blue and the green are either the cancer drug by itself or the cancer drug wrapped in those cell membranes. The mice were given a total of 4 treatments with a 48-hour break in between. So they were administered over a period of 1 week. And they basically injected those mice with a fluorescent dye whenever they needed to visualize those tumors. But basically what you can see is after that treatment, of course, all the tumors eventually started growing again. But the group that had the algae, actually, it grew very slowly, while the others, it was kind of comparable to saline. It was the drug alone didn't do any better than just placebo. So this graph on the right here shows the survival time. And each one of those steps down is a mouse that was succumbing to lung cancer. You can see these mice that were treated with, just the drug alone didn't seem to do so great. But the mice that were treated by the algae, they really seemed to do pretty well. And when the mice passed away, they, of course, basically dissected them and looked at all their different organs. And they really didn't find any toxicity in the organs, at least from the algae-treated group. Here's what they had to say. The traditional pharmacokinetic assessments in blood and biodistribution in other organs do not apply to this study due to the localized delivery method. Compared with the free drug and drug-loaded nanoparticles, the biohybrid MicroRobots exhibited enhanced tissue accumulation and extended retention in the deep lungs. The prolonged drug retention could be attributed to the unique motion capability of the microalgae, which enabled them to evade phagocytosis by alveolar macrophages. So basically what they're saying is those algae were able to avoid, for a longer period of time, getting consumed by the mice's immune system. Anyway, here's the title of the study if you want to look it up. I don't know if this is something we're going to see in humans anytime soon, but pretty cool, in my opinion.